Okay, welcome to Corey Rossman Schools. Although if you watch this video, I'm at a different school at that point, and it has my information for that other school. But they still use green and gold. I didn't have to change my clothes very much. So if you did this lab, determining the largest mass of a granite sphere, there's water pumped under this thing. And what we're going to do in this lab section is figure, okay, what's the pressure of that water in order to hold that, levitate it for lack of a better word, and what is the density of that granite. Okay, so that's what this section is about. So the pressure is the force per unit area. I think on that ball that the circumference here was like 2.81 meters or something like that. And it took like 12 or 16 newtons of force to pull it, and it was like 12 seconds. And I think it was 2.86 meters. But anyway, if you take that string around the bottom where the water is pushing it up along that rubber gasket, that's 2.29 meters. So you'd have to measure that on whatever sphere you have. And so you would take that circumference, which is what? Circumference is what? 2 pi r, 2 pi d? I'll think about it. 2 pi r, pi d. Okay, so then you'd use that to find the radius, and you use that to find the area. And you don't worry about the fact that's curved, because the way the vectors work out if you put it down into a little grid, it's still a circle. Okay, so that circle is pi r squared for that area. So you could use the circumference to find the radius, to find the area, and then you have this. So then the pressure under there is mass of this thing, which I think is 1,031 kilograms from that previous video, times gravity divided by that area. And your kids can figure that out. That'd be the pressure. Now what about the density? Okay, so the density is equal to the mass per unit volume. And the volume of a sphere is 4/3 pi r cubed. I'm not going to get into that here, but I think my second of the two videos on that, I talked about that extensively. That's the volume of a sphere. So you got to put your radius in there, and the mass you'd have, and so you can get the density of that sphere also. So when we go from the rotational stuff in my class to the fluid stuff, it's in the next chapter. I just take that same lab and use the data to work a couple fluid problems in the lab. Have a good one.